Okay, students, very good afternoon once again. Okay, students, so today we'll continue the diffraction. Yesterday I started already.
Condition for constructive element. Yes, sir.
Condition for
Constructive intervals. Then you
next.
start an intensity, then you erase the.
Yes, yes, very good.
Impedance takes.
Very good, very good. I remembered. Huh? How? Yesterday, what you did? Who told to attend online? Then for me only punishment if your network issue. Teaching topics we have to cover, no? Extra you come. I will explain. What do you want? I will explain. Okay. Don't attend online maximum, everyone. Or else keep Wi-Fi in your house. Don't attend with that phone hotspot or anything. Why? Because when you are using only phone in the Zoom app, na, video will rupture, audio will rupture, quality will differ. No, if you have Wi-Fi only, at least moderate Wi-Fi is enough. Good Wi-Fi. Fast speed is not required. So then only you attend. You come that topic, I'll explain. Today I have to cover teaching topics, and Monday test revision also I will give numericals. Physics pathetic score is coming. This is our marks.
Sir, how that 16 mark games are I didn't attend the test last week in physics.
You attended, no?
I didn't attend, sir. You do ask why you didn't attend. Everything 0-0-0 game.
This is October 17th, last.
After last week I didn't attend, sir. October 17th.
Then who attempted this?
That 16 is coming. Vishal is saying I think it will be grace mark for.
Maybe grace mark. Tell your admission number.
188.
188. 9540, no? You even did not attend, huh? Did not attend the test, huh? Date this one?
17.
How you know? I mean this result only, na? Previous here it is showing 0.
There it is showing 16.
You have any sleepwalking habit? Sleepwalking? No. Okay, some technical error. Ignore it.
Okay.
Okay, so today, Vishwanath, come once again. I'll explain. What do you want? Why? Because they already listened, no. So for you, specially, we should not disturb the class. So you specially come. Specially, I'll explain. You take one slit or aperture. What the name of this? One hole or one slit or one aperture. Okay, so behind one point source of light is there. What is this? One screen. What is the diameter of this slit? A meter or D meter, your choice. I'm using monochromatic light, yellow color light. In all experiments, we use monochromatic. Mono means what? Single. Chroma means what? Color. Yellow color light we will use. Its wavelength is lambda. So this is the axis of our arrangement. Every distance is measured from the what here? Center of the screen. As I told you, we are investigating one particular point P. I mean some light waves coming from the aperture or from the slit. They will undergo what type of phenomena? After falling edges, they slightly bends now, and that between the bent waves, again one more phenomena takes place, interference taking place. Here now question will come at point P, what the thing is formed, maybe bright band or dark band, correct or not? So at the center of the screen, definitely central maxima will form. I will assume the central maxima intensity is I naught and it is maximum. At point P, what will happen? At point P, either bright band will form or dark band will form. So tell me, what is the intensity at that point P? I naught into how much? Sine square beta divided by beta square. This is the expression for the intensity at a particular point P on the screen. I'm requesting you to remember. And beta is nothing but pi into A into sine theta divided by lambda. From the midpoint of the slit, if you join one line towards P, the angle subtended between x-axis and the line joining center of the slit and the point P is called angle of diffraction. What a theta is called here? Angle of diffraction. Angle of diffraction, where A is called here diameter of the slit or length of the slit, slit length. Then if you substitute the beta value here, so what is the intensity at that particular point? I naught into sine square beta. Beta value how much? Pi a sine theta divided by lambda and whole divided by how much? Beta square means pi a sine of theta divided by lambda whole power 2. Okay, so this is a very important expression. With this expression, no need of proof, but problem solving purpose, I'm requesting all compulsory you have to remember at your fingertips. And if you observe the intensity pattern, this is a single slit. If you perform this activity without lens, the type of diffraction is called Fresnel class diffraction. What the name of this? Fresnel diffraction. Fresnel is a name of scientist. He performed this diffraction activity without a lens. And if you see the center of the screen, this is the, let's say, x-axis. Let's say this y-axis. On x-axis, I am plotting intensity. At the central maximum, what will happen? It is central maxima. It is also called airy disk also. What is the name of the disk? Airy disk. In real, if you see, this is the central maxima, or one bright circular disk is called air disk and surrounded by fainted bright fringes and circular fringes will be there. As you are going away from the center, what will happen? Intensity keep on decreasing like this. This is a major difference between interference pattern and diffraction pattern. In interference pattern, all bright bands are what here, students? Having the equal intensities, no? Correct or not? But here, only the middle thing only very bright. And this one is what here? As you are going away, the intensity gradually decreases. Yes or no? Like this. As you are going very far means what? So the fringes are getting fainter and fainter. The last one you cannot notice also with your naked eye. Okay, now also you can see the shadow. Every shadow is a perfect shadow, but every perfect shadow is having some fainter shadow part also. That fainter shadow formed because of this diffraction only. Understood? Here also same thing. Now, if you see the this diffraction effect on our telescope. See, at very now you are coming, Srinidhi? Oh, okay. So telescope, for example, student, already we discussed what is the telescope. From very far a distance, two people are standing adjacent like this. Can you identify your naked eye? Can it identify as a two people? Huh? Very far. You are seeing a dual star. You know, in the nature, dual stars will be there. Dual star means what? The two stars are very close and they are revolving at their common center. But as you are observing from our planet, your naked eye can resolve them. Resolving in the sense, now I can resolve you. You are sitting very near to me. I can resolve Kirutika Kalpana separately. Jiva Kamal, Vishwanath separately. But if you are sitting in some Mars planet, can I resolve you? Can I identify? Can I recognize you separately? If you are sitting in the one farer tree, I will feel that only one man is sitting. When I come close only, my eye will observe that, oh, these are not one person, only two people are there. Yes or no? Some birds, how they will fly? As a group only, no? Correct or not? You will feel that they are one only. If you are from very far vision, if you see, you will notice some group of creatures are growing. One creature is going, you will feel. But when they are come closer only, you can recognize, oh, these are birds, they are moving together. Correct or not? So, ability of every optical instrument to distinguish the separate images is called what here? Resolving power. Resolving. Resolving means what? Resolving means what? That two images or multi images we can separate. Actually, we are seeing white light. Actually, it is a mixture of 7 colors. But why your eye cannot resolve? Why prism can resolve? You see through prism only, dispersion taking place, then only you can resolve the 7 colors. Means that prism is having good resolving power. I mean, it can resolve even smaller wavelength also. But your eye doesn't have that capacity. So you can, I want to write one statement, resolving power. Resolving power. Are you seeing me or are you seeing my image right now? You are not seeing me. No one will see objects in this world. You are seeing my image. You are recognizing my image that which is falling on your retina. Are you understanding? If you are seeing directly me without aid means what? Without spectacle, you are seeing my real image. But Srinidhi is watching my virtual image. Are you understanding? Anyway, both of you people watching image. So how I can define the resolving power? The ability of any optical instrument. The ability of any optical instrument. To distinguish or to separate the images. To separate the images which are very close. Understood, students? So different optical instruments like telescope and microscope, they will have the different resolving powers. Now let us try to understand about telescope. So what is the telescope, students? For example, Just imagine this is one telescope. Actually, how many lenses are there? Two lenses are there, but instead of two lenses, with your permission, shall I imagine that one lens? Any problem to you? No problem, na? So this is a lens that you have used in the telescope.
Eyepiece or
Two lenses. We are instead of two lenses, I'm visualizing only one lens. No problem, no for you. Any problem? Huh? No problem. Na? Here one object is there. Object number one. Here one object number two is there. Okay, they are very close. What will happen? Tell me. Their images will form somewhere. Actually, we are talking telescope means where image should form. This side should form, na compulsory. So somewhere their images will form. Here somewhere I1, somewhere I2 will form. Have you noticed? Even though they are very closer, but after refraction, their separation between the two images are enlarged or not? Correct or not? So if it is telescope means it should have greater magnification. Very clearly you can identify. When you are seeing two stars that are very close, but when you are viewing through telescope, with your naked eye, if you see the sky in the night time, you will see as a single star only. Understood? These O1 and O2 are very close. But when you watch that images with the aid means what? Telescope, definitely the gap between the two images will increase. That will differ, depends on this focal length of the two lenses only, na? Kindly say yes or no. So that if you see, join some lines of the image 1 and image 2, the angle between the two images is only called angular resolution. What a delta theta is called here? Angular resolution. Angular limit also, many names are there. Angular resolution or angular limit also you can pronounce. Different books will have different terminology. Are you understanding? So that here we are using a wavelength, let's say lambda. If you imagine this is happening in our laboratory, I told many times which source of light we use as a monochromatic light, as a sodium lamp, means yellow color light only we will use. Luckily I am using yellow color only. Okay, means we can have one standard formula for the angular limit. Delta theta equal to how much here? 1.22 into lambda divided by a here, students. Understood? What is the lambda equal to here? Wavelength is A is nothing but the slit. This is only slit, no? Lens is only acting like a here diffraction device. Understood or not? So this is a length, diameter of this effective convex lens. This is called what here? What do you say? Angular limit. Angular size or angular limit or angular resolution of that telescope. So if the power is very high means what? Even though the angular size is small also, it should show more power, no? Correct or not? So I can write resolving power of the telescope. Resolving power. Resolving power of telescope is inversely proportional to delta theta, na? Resolving power equal to, shall I write inversely proportional to delta theta, no? Means if angular limit is very less, then only power will be very high. Correct or not? The angle between the two objects should be very smaller. Then only there is a necessity of the telescope. Not understood? Huh? What is the use of the telescope? To coalesced objects. two water droplets are coalesced. When you are seeing from farer, you will think that that is one drop only. When you will notice that two drops with a telescope only, it is possible, na? Yes or no? Huh? No. When it is far, I am talking. Microscope also it is there. Microscope with the microscopical microbes only. When you are seeing raindrop is not a microbe. When you have to use microscope, when you are viewing very micro level organisms like bacteria, virus, etc. Correct or not? Okay. So right now our discussion is only telescope. So what is the necessity of this resolving power? If the angular size is very less, then only we are expecting high power telescope, no? Correct or not? So it is inversely proportional to angular limit. Substitute delta theta value here. What is resolving power of this telescope? 1 whole divided by 1.22 lambda by A. A, if you take that side, what will happen? Resolving power of the telescope, how much? A by 1.22 into lambda. This is called what here? The resolving power of the telescope. Direct questions will come, students, based on the angular resolution or angular limit and resolving power of the telescope. I'm requesting all compulsory you have to remember at your fingertips. My point clear? Next, microscope. Every optical instrument, including your eye also, should have some less or more resolving power. Understood? Your eye also recognizing me. Correct or not? What is chair? Pen tab is there. You can recognize two letters are there, not T and E. You are recognizing separately. When they are very far, when they are more than 7 meter, can you recognize? I will take this to more than 7 meter. Meaning at infinity. Can you recognize? You can recognize, but that two images of T letter and E letter will be coalesced. Correct or not? That's what you have to use these optical instruments. Correct or not? Now let us see the resolving power of the this thing. Microscope. What is that? Microscope. Microscope also having many lenses, no? Correct or not? But I will treat like a single lens. What lens? Single lens I will take. And here one, this is a axis of the lens here. Here somewhere point of focus. If you join the line between, I mean here also point of focus is there. In your left side, we have the habit of keeping the objects, no? So the angle between the line joining edge and the point of focus and with x-axis called beta here. And let's say here length of this aperture, you take 2a. What is acting like a diffraction device, like a slit? This lens is acting like a slit here. Yes or no? When you are seeing the two microbes which are coalesced, okay, this is a O1 microbe and this is what here? O2 microbe. Where the image will be formed? Compulsory here only, na? I2 somewhere and I1 somewhere. Correct or not? Now with the microscope on, huh? If you don't like, you can take A, no problem. In the book it is given 2A, so I am also taking. Who discovered that? Okay, that he should know. Clear or not? There A only will come. Here 2A. No, if you don't want, if you don't like means take A, no problem. Understood? Okay, that is your choice. Then equation you have to adjust. Okay. Now if the, have you noticed before O1 and O2 are almost all coalesced and there is no significant gap. But once the final image formed, have you seen the gap between the two images? Yes or no? Let's say the refractive index of this lens is mu. Okay. What is the angle between the two images is called what, students? Respond. delta theta. Correct or not? So the product of mu into sine of beta is called what here? The product of 2 into refractive index and sine of beta or beta is called a numerical aperture. What is that? Numerical aperture. Understood? Now tell me, what is the angular resolution of these two images? Or you can also call it as angular limit also. How much? Tell me. That is 1.22 lambda divided by 2 mu into sine of beta. I'm requesting you all kindly remember at your finger. I mean, this is acting like a length of the slit. That's all. In the place of A, I mean, length of the slit, you have to keep what here, students? 2 into mu into sine of beta. Are you understanding? Now tell me, as I told many times, what a resolving power of any optical instrument is? Inversely proportional to or reciprocal of this angular limit, no? So how we can write resolving power? Respond, resolving power is nothing but resolving power is inversely proportional to what? A reciprocal of angular limit, no? So substitute 1 by delta t value, how much here, students? 1.22 lambda divided by 2 mu sine of beta. So this is a very, very important expression, student. I am requesting all compulsory you have to remember. Direct questions will come. Resolving power of this microscope. And if you see through any, so this is any convex lens or any microscope or telescope of your choice. And this is the axis of the lens. Here somewhere point source of light is there. This is a screen. Tell me, what do you expect the screen? Because of the diffraction, if you imagine this is a screen, what do you expect at the center of the screen, students? High intense airy disk you can see, no? Correct or not? So surrounded by very fainter bright bands, I mean, sorry, band I should not use, very fainter bright fringes and dark fringes you can see. Such a region where the maximum brightness is occur is called Rayleigh's region. What the name of that region? Rayleigh is the name of scientist. Rayleigh's region. So the radius of this Rayleigh's region is, this also only is a memory required, friend. Lot of theory is there, no logic. So the Rayleigh's region radius R is given as that equal to 0.66 lambda by A, where A equal to length of the slit or lens, I mean diameter of the slit. So what is this is called here? Radius of this Rayleigh's circular region. Understood? I mean radius of the airy disk also, or radius of the central maxima also. Understood? Or radius of the primary maxima. Except the central maxima, all are called subsidiary maxima or secondary maxima. Their length, how to find, yesterday only I have explained. Clear? These are practical results, so that's what I am introducing directly. Is my point clear? So next one, Fresnel distance. Fresnel distance. Fresnel's distance. That is denoted with the ZF. For suppose students, this is any hole or lens or any circular aperture or any obstacle. There is no rule that it should be hole. There is no rule that it should be a lens. There is no rule that it should be a water drop, anything. Behind that, I kept one source of light. And what is the name of this line? Axis of the slit. What is the name of this? Respond. Response to screen. Let's say the distance, diameter of the slit equal to a meter. Let's say the distance between the screen and plane of the slit is how much? Capital D. I'm taking one particular point P. At point P, what might be happening? Huh? Point P, anything may happen. Bright band, bright fringe may occur. Dark fringe also may occur. That is depends on the path. For example, from the center of the slit, you join one line. So this angle is only called what here? Diffraction angle. Theta is called what here? I already mentioned. Diffraction angle means bending angle. The light ray, instead of going straight line, after falling on the edge, they are slightly deviating. And let's say that every distance we are measuring from the center of the screen. So the distance between the center of the screen and point P, how much? Y. With your permission, shall I write tan of theta equal to how much, students? Opposite side by adjacent side. But all angles we are taking as a very little angles, na? With your permission, tan theta, shall I write theta? Yes or no? So what I can write? Y is equal to capital D into theta here, students. Yes or no? But for a minima, if you assume here first minima is there, tell me what is the condition? For example, if you imagine this is the central maxima, for example, what is the name of this point? First minima, na?
Yes, sir.
In between first minima, two first minima only, this central maxima is captured. Kindly say yes or no.
Yes, sir.
Okay, so what is the condition for minima? Yesterday I told you. A sin of theta equal to how much? N lambda only, no? Have you remembered a condition for minima? Path difference is A sin theta. I told conditions will be reversed for interference and diffraction. Their maxima condition in interference here become minima conditions. So this is a minima condition, nth minima condition. So A into, with your permission, theta shall I write? First minima means 1 into lambda, na? So theta equal to how much here? Lambda by A. I will assume this is equation number 1 and equation number 2. Put equation number 2 in equation number 1. What I can write? Y is equal to D into theta value how much? Lambda by A. Understood, everyone? So what is the Fresnel distance means? Actually, I told you, students focus here, this point, some confusion will come. Actually, what is our problem? Our problem is we are not getting a perfect shadow. We are not getting a perfect bright patches. You are seeing, I think 3 days before solar eclipse came. Solar or lunar? Solar, na?
Yes, sir.
Solar only, I think.
Yes,
Daytime occur means solar only. When solar eclipse is occurring, in between Earth, planet and Sun, who came? Moon came. Moon completely overlapped the Sun. So, even though overlapped, have you noticed some brightness along the periphery of the Sun? Why that brightness came? In middle, perfectly it should be dark, na? During the solar eclipse. But the edges of the Sun still brighter. Why? Because of the diffraction only. When the light do not bend, when light do not diffract, you could see full dark patch, no, during the solar eclipse. Say yes or no? Understood? Correct or not? Means this is a fight between particle nature and wave nature. Just imagine light does not have wave nature. What do you expect? Do you expect this silvery portion along the periphery of the sun? No, you will expect this only, na? Full dark, na? Even you won't be noticed also that solar eclipse. Because of that peripheral brightness only, you are identifying that is a solar eclipse. Are you understanding? Means surely that is wave nature. Light is having wave nature. Wave nature means surely it will bend so that portion will be seen. Now, if particle nature is there means only full perfect dark patch is formed, na? Correct or not? I mean, tell me.
Yesterday you said if TS having particle nature, it will be around this room, it will not go out.
Yes.
If moon is coming in between sun and the earth, how it will pass through that and will come, sir?
I did not understand.
You said if light has particle nature,
Hmm.
the full sun we can see. You said no, sir. In the lunar solar eclipse.
No, I didn't tell like that. I didn't tell like that. I will tell. See, total world, how they know that is a solar eclipse, right? Moon completely overlapped the sun. Na? Moon and earth and sun comes into the same straight line. Correct? In that process, moon completely overlapped the sun. I am telling, once moon fully overlapped sun, overlapped or not, accepted or not? Overlapped means if the light is having particle nature, I am telling the edges is not brighter.
Okay.
Why edges are brighter? Because of diffraction. Light, the light coming from the sun falling on the edges of the moon and diffracting and coming to earth. There is no diffraction. I am telling you could not enjoy that solar eclipse or lunar eclipse. I am telling. Even you cannot identify also.
It is having wave nature, no, sir. Light is having.
It should have wave nature now.
It must pass through the moon and it comes, no, sir. Yesterday you said that.
That is not. That is quantum nature again. That is quantum nature. Quantum nature means. Quantum means what is it? It will pass through everything. If you have quantum nature, during the lunch break, you can go to your past 500 years before, 50 years, future also you can go. That world is different, quantum. Currently, that much advanced discussion we are not doing here. In the quantum world, everything is different. Are understanding? In the quantum world, I can dilate you, I can magnify you. Are understanding? If I say you will go to sun, that world is different. Leave that quantum nature. Only focus on the wave nature.
Okay.
Understood? So wave nature in the sense, when the light coming from the sun falling on the edges of the moon, bending taking place, diffraction taking place. So that's what that the edges are brighter. I am telling that's all. Here quantum nature is very advanced discussion, student. Right now that is beyond our scope. In your advanced, in your PG level, UG level only we will discuss. Okay? Are you understanding? Okay? Actually, what I am trying to say right now, there is a fight between particle nature and wave nature. How I should say, for example, there is a micro limit between when light is losing particle nature and gaining wave nature, only little limit is there, no? Correct or not? When it is losing particle nature, at that moment only when it is acquiring wave nature, no? Correct or not? At that limit, what will happen? At that limit, what will happen, friends? The sun, I mean that slit, that obstacle would be like this only. It's a perfect dark patch. When it is growing its wave nature, then only this peripheral region will be getting brighter, I am saying. As the wave nature is increasing means on the edges, brightness will be growing and growing and growing, I am telling. Correct or not? So such limit where losing of particle nature and gaining of wave nature is only called Fresnel limit. So that distance is called Fresnel distance. Means as you changes the distance between this is slit, no? Circular slit, no? Correct or not? This is a screen, no? Correct or not? This is a point source of light, no? Means if you are adjusting the distance between the plane of the slit and plane of the screen, at a particular time, you can minimize maximum fainter fringes, no? I repeat the statement. You are adjusting the distance between this aperture, I mean slit and the screen. At one particular distance, what do you notice? Very nicely, bright patch and surrounded by fainter fringes you notice. Why you notice with your naked eye? Light is more dominant at the wave nature. At this distance, light is showing more wave nature. Now you brought very closer. Do you notice the diffraction pattern? Do you notice? As you are bringing the screen very close to the slit, what will happen? That central maxima, that airy disk is getting magnified, and this fainter fringes will be entered into the central maxima, and slowly that fainter fringes will disappear. What does that means? Means at that distance, the light is left the wave nature and very nearer to particle nature. At that moment, what do you notice? Only you will notice only dark patch. Only you will notice only airy disk. Yes or no? Such a distance between plane of the slit and screen is called Fresnel distance. Understood or not understood? And at that moment, so I will fresh page, I will take, no issue, no? You copied this? First class, how many came? Only Dharni. What about others? What about others? Vishal not feeling well. Kabil? Any festival effect on rally is going on? Or you don't know these people? Tamil one big festival is there for them. Today local holiday. They may be outing or anything. Devar Jayanti, yeah? Huh? Others? Maybe in that festival mood, rallies they are going. Okay. I hope you understood what is the Fresnel distance. Right now? At that Fresnel distance, tell me what is the scenario? Yes. It can't make perfect particle nature, it can't make perfect wave nature. Nothing, no perfect, no? Correct or not? At that moment, you just minimized the effect of wave. Correct or not? At that moment, if you see the slit, means the This is a one circular slit. This is a screen. And what do you notice? Respond. Here you can see only what here, students? You can see only perfect ideal concept I am explaining. Only you can see bright patch only, no? Correct or not? What is the meaning of bright patch? Perfectly particle nature only acquired, no? Where are all fainter fringes? They're gone. Correct or not? Means at that moment, this distance between the plane of slit and the screen is called Fresnel distance. That is exactly equal to capital D. And in fact, the fairy disk is there, no? Sorry, airy disk. Airy disk means what? Full bright patch is there, na? That bright patch also should be equal to Z, I am telling. Understanding or not understanding? And if you,
Radius of the bright
fringe also Fresnel, both will be almost all same, I am telling. Correct or not? At that moment only, it is an experimental observation only. When the distance between the plane of the slit and screen exactly equal to what here? Radius of that airy disk, then only that light will lose its complete wave nature and will acquire particle nature. And on the screen, only what do you notice? Diffraction pattern. You don't notice. Only what do you notice? Only bright patch only you will notice.
we will not see the diffraction.
You cannot notice. Only particle nature is there, na? If particle nature is there, how it will perform diffraction activity? Understanding or not understanding? So that is our observation. So I will assume this is Y. As I told just now, if you join the edges, this is theta, na? What a relation between this Y and theta? Y is equal to how much? D into theta, no? Kindly say yes or no?
Yes, sir.
Y equal to D into theta value, how much? Just now I told lambda by A. So here D become Z experimentally, Y also become Z. So substitute Z equal to how much? Z only, na? Sorry, A must be equal to how much? Z. Wait a second. Z equal to how much here, students? Lambda by A. Sorry, D must be equal to Fresnel distance. So I could write Y is equal to how much here? Compulsory. Fresnel distance Y is equal to D lambda by A. And D is nothing but what here, students? D nothing but Z only. So D equal to how much? I can write Z into lambda divided by A. So Z equal to how much? Fresnel distance? Y into A by lambda. So here Y must and should be equal to compulsory, not Z, students. This is a 1 by Z. I mean the reciprocal of this must be reciprocal, sorry, here. So if you substitute this Y value here, what we can write? Wait a second. Z equal to, just a second here. Confusion. What happened to screen? But it is under the process. Yes. Raise it, it will come.
Raise one more ticket, sir.
So here, students, Z equal to, I can write, see here, the Z value exactly how much? A into Y by lambda. And here compulsory Y must be equal to exactly A. This Y is there, no? I mean, this distance is Y, compulsory, this should be equal to A, exactly. But here in this scenario, you have to take this as a 2A. In this scenario alone, what the diameter of the slit here? Not A here, A plus A, how much? 2A. So compulsory Y should be how much here? Compulsory A, so substitute here. So Z equal to how much? A into A square by lambda. This is the expression for what here? Fresnel distance. So I am repeating the condition, students. So at this Fresnel distance, means when Z equal to capital D and when that radius of the airy disk or bright patch compulsory must and should be how much? Yeah, then only what will happen? Light completely, what it lose? Completely loses what type of nature? Wave nature, and it will have only particle nature. So only you can see the bright color patch here. That is the concept of Fresnel distance. Direct questions will come, students. So you people compulsory should remember. So just a second. I think this is not A. The length of the slit is A only here. Small change. Please correct. Here still the length of the diameter of the slit how much? Not 2A, A only. So this at this distance only, at this adjustment only, if you keep the exactly at this distance, you have to keep it in your mind, these points. This radius should be A, and this length of the slit also should be A at that moment. Only bright patches you can see, no fainter fringes you can see here. No fainter fringes you can see. Such a distance is called only Fresnel distance. Okay, so that's all about the diffraction. Now, very immediately, I want to introduce one more phenomena. When period will over? 240. So polarization. Polarization is there a tomorrow exam?
No, sir.
What is the tomorrow test portion?
Till that shift in 15 interference. 15 interference. 15 interference. No.
Okay, wave optics.
Remaining
Okay, students. So next Saturday, Sunday, remember me, why? Because polarization is pending. Polarization is pending means wave optics is over. That is 15 minutes only. Okay, so now have a break. Thank you.